Hi, and welcome to the We Gonna Make It podcast show, your go-to podcast for all things emerging tech. Today we're talking about a new innovation on the Solana blockchain that's changing the game for non-fungible tokens, or NFTs. We'll be discussing what state compression is, how it works, and how it's going to impact the world of Web3 experiences. Solana has been a leader in building Web3 experiences at scale thanks to its speed, minimal environmental impact, composability, and low gas fees. But now it's about to become even cheaper to build user-first Web3 projects thanks to state compression, a new way to store data directly on-chain that cuts down on cost by magnitudes of scale. State compression is already being used by several teams in the Solana ecosystem, including Dialect and Crossmint, to power large user-friendly experiences. Compressed NFTs are the first use case for this innovative technology. They're just like regular NFTs, but drastically cheaper. Minting 100 million compressed NFTs would cost you just 50 Solana to store on-chain. While if you would do that for uncompressed counterpart, it'll cost you about 1.2 million Solana. This means that the cost of an NFT on Solana now is as little as cost of a single transaction. State compression also takes advantage of Merkle trees, a data structure known for its capability to compress the verifiability of a tree of data into hash or fingerprint of the current state of the tree. The Merkle roots are stored on-chain, and the updates are stored directly in the Solana ledger. So this allows anyone to verifiably and permissionlessly reconstruct the tree, combining a vast amount of verifiable off-chain storage with a low overall cost of on-chain storage. Solana Labs and Metablux built state compression, while Helios, Triton, and Simple Hash provided support as RPC providers and indexers. Phantom, Solflare, and Solana Foundation provided the additional support. State compression is making it easier for enterprise companies to drop NFTs on a massive scale. Crossmint, an NFT tooling and API company, has already minted roughly 300,000 NFTs for holders of Crossmint Wallet to recognize them for being early adopters. This drop demonstrated the efficiency of state compression for a straightforward use case. A standard NFT mint on Solana costs about 0.012 Sol, or roughly 24 cents. Which is too much for mass-scale use cases like ticketing. In Crossmint's case, delivering NFTs to 300,000 users under normal circumstances would cost $74,000. But with state compression, that cost is less than $200. Crossmint is also building no-code tools that plug directly into Zapier, allowing creators and brands to reward customers with digital tokens based on certain actions and no code. The company is also experimenting with other possibilities that were too cost prohibitive to consider before. So this technology has the potential to change the landscape for a wide range of blockchain applications, particularly those that involve large amounts of storage on-chain. The first use case which we discuss for state compression is non-fungible tokens, which have already seen significant adoption across Solana ecosystem. But there are many other applications that could benefit from cost saving and efficiency gains that state compression provides. One example is decentralized finance protocols, which often require large amounts of data to be stored on-chain. With state compression, the cost of storing this data could be reduced by several orders of magnitude, making DeFi protocols more accessible to users and developers alike. Another potential application is gaming, where in-game assets such as characters, items, virtual lands can be represented as NFTs. By using state compression to store these on NFT chains, game developers can reduce the cost of storing and transferring these assets, making them more affordable for players. State compression could also be used to store and manage large datasets such as medical records or supply chain information. By using Merkle trees and state compression, these datasets can be stored on-chain in a secure and efficient manner, reducing cost of data storage and improving data accessibility. Solana's state compression feature could potentially strengthen the argument in favor of Layer 1 scaling solutions, as it allows for more efficient use of on-chain resources such as storage space and network bandwidth. This means that Solana can potentially support more complex and data-intensive applications on the base layer itself without sacrificing performance. Layer 2 solutions, on the other hand, typically rely on off-chain mechanisms to reduce the amount of data that needs to be processed on the blockchain. While these solutions can be effective at scaling certain type of applications, they may not be well suited for applications that require frequent on-chain interactions or large amount of data storage. So overall, Solana's state compression feature adds to the growing set of tools that developers have at their disposal to build scalable blockchain applications. While the debate between Layer 1 and Layer 2 scaling solutions is likely to continue, it's clear that both approaches have their strengths and weaknesses, and the best solution will depend on the specific requirement for each use case. So in conclusion, we've explored the game-changing impact that state compression and compressed NFTs are having on the blockchain space. By taking advantage of Merkle tree data structure and the speed and scalability of Solana, compressed NFTs are making it possible to mint and distribute at a fraction of the cost, opening up new possibilities for mainstream adoption and enterprise use cases. The beauty of state compression is that it not only reduces the costs but also increases the efficiency and the speed of on-chain data storage, allowing developers to create more complex and immersive experiences while still using the security and decentralization of Solana's base layer. As we wrap this podcast up, I'm excited to see what the future holds for this technology. The potential for innovation and growth in the blockchain space is vast, and I can't wait to see what new and exciting developments emerge in the next coming years. Thank you for joining us today, and we look forward to sharing more insights and discussions on the latest trends and developments in the emerging tech space. Catch you in the next one. Goodbye.